Swayam Prabha. Digital India. Educated India.
Hello everyone. Now our present topic is comfort and functional properties of textiles for human protection. Like we can create protection, we can create protective textiles, but we have to see ultimately it has to be used by the wearer. So, if we do not create the comfort, if we can incorporate comfort within that protective textiles, it is useless basically. So, this trade off scenario we will use here in this segment, and also we will try to understand the basics of comfort. So, we will try to explore the science and innovation behind the textiles that protect while ensuring the wearer comfort and performance. So, that if the wearer is not comfortable, he will not be able to perform. Okay. So, this issue we will discuss here, this trade off, which is very important to understand before designing any protective textiles. Like suppose we are creating one mask. If the mask is not breathable, or if the people are people will he is not able to breathe properly, so it is useless basically. So, that we will be discussing in this scenario. So, dual challenge here, protection meets comfort, okay, that these are the dual challenge. So, protection we can create protection, but comfort we have to create also. So, protection requirement, what are these? The protective textile must shield wearer from multiple hazards, including extreme heat, extreme cold, hazardous chemicals, harmful microbes or mechanical threats. These materials serve as a critical barrier in life threatening environment. So, this protective textiles are a critical barrier, but at the same time we need comfort, which is essential. For protective gears to be effective, it must be comfortable enough to wear. This means managing thermal regulation, controlling moisture effectively and preventing a pleasant tactile experience that does not distract or burden the wearer. So, it should not, that tactile experience should be good, so that it does not distract the wearer for perfect activity. Okay. So, that is important. So, we must have some balance, we should not sacrifice the protection, at the same time we should maintain the comfort. Okay. So, balancing this conflicting demand, which is very important. You can see here this, here the textile engineers should work on this, on the material science and on the design, on the yarn structure, fabric structure. So, in every areas people should work to create this conflicting demands. So, what is the definition of comfort in protective textile? It is basically it is defined by in the areas thermophysiological comfort, like our protective textile will always interact with the human body, okay, and the human body generates heat during the performance, and the heat balance has to be there, okay. Thermophysiological comfort, and there it also includes the moisture. So, the moisture sweat, moisture vapor it generates, it should actually manage the this moisture. Okay. Next is sensorial comfort, tactile sensation that matters, okay. Softness against the skin, and it should be body it should follow the body contour, it should not be rough, it should not be scratchy or prickle sensation should not be there. So, all these are coming under this sensorial comfort, and also psychological comfort, which is very important, which should not go unnoticed. Whereas confidence, like design of a protective textile, it should look nice, whereas confidence and peace of mind, okay, knowing they are actually they are fully protected. So, that is the important, they should be actually psychologically they should be protected, they should feel that after wearing the this cloth they are totally protected. So, that means they must know this is actually having some standard, this follows this protective garment which he or she is wearing, it is actually it is as per some standard protocol. Okay. So, real world example is that modern flame resistant fabrics now incorporate moisture wicking technology, breathable design. So, flame resistant textiles clothing we can always create, but we should create at the same time we should create the it is a moisture wicking characteristics or breathable design, okay, that allows the firefighters and industrial worker to stay protected while they are comfortable during wear. So, if you see the comfort by definition, it is a state of pleasant neurophysiological, thermophysiological and psychological harmony. So, that harmony should be there, okay, between a human body and environment. So, human body always interact with the environment. So, this type of pleasant harmony should be there. It is basically comfort deals with basically thermophysiological comfort, sensorial comfort and aesthetic comfort which is psychological. Okay. Why comfort in protective clothing? Because as we have already mentioned, comfort is crucial in protective clothing because it directly influences worker compliance, safety and ensuring its the gear is worn correctly during high risk task basically. So, the gear this protective gear the worker should wear correctly and they will wear correctly when they are comfortable. Okay. Without comfort, user often modify or skip protective elements. Suppose the clothing is it is not comfortable, the gloves, suppose protective gloves, if it is not say breathable. So, then what will happen? The moisture generation will be there within the microclimate and the worker will actually not use that gloves and compromising its protection level. The regulatory bodies are there like OSHA, Occupational Safety and Health Administration, US based body. They emphasize the fit and comfort to bridge policy with real world use. So, they are what they are doing along with the comfort regulation, they try to create the comfort, bridge the comfort within that protective textiles, and this comfort boost the compliance. Okay. Like the uncomfortable protective clothing leads the worker to wear improperly. They will wear the things will be the protective gear improperly. They will try, like they will try to open the zipper. Okay. For any, that means the protection is like in your PPE kit in medical application. If someone opens the zipper or some opening is there, so then the protection level is compromised, or sometimes they try to remove everything if they are feeling uncomfortable. That will actually weaken the chain of safety. So, that is very important, that we should, that chain should not be broken. The comfort features like lightweight fabrics, breathability, stretchability, softness, prevent heat built up, moisture retention and restrict movement. So, this these are the features. Lightweight, it should be lightweight, it should be breathable, it should be stretchable, and softness should be there, and it should prevent heat build up. So, heat should actually move from the human body to out environment. It should prevent the moisture retention, it should be absorbable, it should, moisture should transmit through that through this clothing, and it should not restrict the movement, body movement should not be restricted to ensure all the, and to ensure full protection during accident. So, the if we can provide all these comfort features, then the user, the wearer will use it properly. So, it will actually enhance the productivity. Like comfortable PPE allows better decision making. So, people can think, if this is comfortable, he can think, he can take correct decision, health maintenance and task efficiency will improve by minimizing distraction like chafing or overheating. So, that is very important. So, multifactorial comfort, physical feel, thermal regulation, ergonomic feel, fit. So, support prolonged. So, if we can incorporate all this multifactorial comfort, physical fit we can incorporate, thermal regulation if we can incorporate, ergonomic fit if we can incorporate, then the wearer will wear prolonged for a long time in demanding environment. The OSHA guidelines highlight the comfort role in encouraging consistent use. So, if we cannot force someone to use consistently, okay, continuously we cannot use, if we cannot provide comfort in the protective textiles, that is important. The key factors here is the breathability, enables heat and moisture escape from dry and which for dry and pleasant weather. So, if we if the moisture gets transmitted from the human body to the environment, then the environment will be pleasant and dry, lightweight and flexible. If the protective textile is heavy, that means that it will actually be the worker, the wearer will be fatigued, actually they will not be able to perform their natural duty, natural performance. So, it reduces the fatigue. So, lightweight and heavy flexible, it reduces the fatigue and support natural movement. Skin softness, it prevents irritation, promote all day adherence. So, the fabric should be soft. Now, the key trade-offs. What are the key trade-offs? The protective textile balance user comfort against the protection level, when where enhanced safety from hazard like heat, chemical and or impact often reduce the wearability. Comfort is sacrificed. Heavier, denser fabrics provide always protection. So, if we use heavier fabric or dense fabric or maybe multi-layered fabric, that will definitely protect us from the from different hazards, but it traps the heat and limit flexibility. If we use very thick fabric, it will trap heat. So, where breathability will be compromised, and then that will not be comfortable. Weight and thickness boost protection, but blocks by blocking the threads, but increases the stiffness, heat built up and restrict movement. So, should we go for heavier fabric or thicker fabric for protection? If we do, then it will compromise it will restrict the body movement and heat built up. So, we have to optimize this trade off. So, moisture management and breathability enhance the comfort through sweat wicking and evaporation, yet high permeable fabric compromise the barrier against liquid and flame. So, these are the trade offs. So, we have to see we have to optimize the design. Protective textiles balance the user comfort against the protection level. So, that balance has to be there, otherwise there will be a problem where enhance the safety from hazard like heat, chemical or impact of often reduce wearability. That is basically, if we try to enhance this safety level, but it will reduce the comfort. Heavier, denser fabric provides superior, that we have discussed this. Now, comfort aspects, softness depend on the fiber blend finish, which aids the skin contact, but potentially weaken the durability. So, if we can create the soft fabric, but for comfort, but it will reduce the durability. Ergonomic design like adjustable fits reduces the fatigue. So, if we can create the ergonomic design, though they add complexity, might lower the uniformity protection. Suppose we create unnecessary a zipper. So, that may sometime useful for adjustable to reduce the fatigue, but creating additional stitch or zipper unnecessarily will reduce the protection level of uniform. So, comfort aspect is there, protection impact, stronger protection risk, thermal comfort or heat stress leading to non-compliance when user remove the gear. That means, if we can create the clothing for a stronger protection, but that people may remove that gear for the sake of the lack of the comfort. So, that will effectively put him in risk. So, for that what we do? We should create a protective textile and then test all the comfort characteristics, but at the end we should use the wear trial technique. So, I will show you on some video clipping where the defense personnel were given the firefighters were given the firefighter suits which were developed and tried to get their feedback as far as the comfort is wear comfort is concerned, but we have tested this for flame retardant, for flame characteristics we have tested different parameters. After doing the, you can see the wear trial, you can see these are the firefighter jacket we had used, okay, we have developed. So, this the firefighters were actually asked to do all these activities in real, and we tried to get their feedback as far as the comfort is concerned. They are doing different activities. So, after that doing so if it is very heavy, we can create a high, very high fire characteristics, okay, protective characteristics, but that that will not be useful. They have to perform all these activities during the in the case of fire. So, this type of activities they should be able to do easily, only then we can create the clothing. Okay. The clothing comfort, the basic scientific aspects are the sensorial or neurophysiological or tactile comfort, how clothing actually interact with our skin and generates feeling, that is the sensorial comfort. Then thermophysiological aspects, which deals with the heat, air, moisture in liquid form or vapor form. So, transmission through the clothing. Then physiological aspects, psychological aspects, which is deals with the aesthetic perception or wearer's attitude. Now, sensorial comfort, which is neurophysiological process in clothing. So, which deals with the two aspects, one is physical tactile aspects. Tactile aspects actually it is a fabric roughness, fabric softness, fabric surface friction, and another is that whether warm or cool feeling. One is tactile comfort, then it deals with the warm or cool touch, warm, hot, cool. Okay. Next is mechanoreceptors, which deals with the external object, mechanical interaction with the body. These sensory responses are basically mechanical distortion of or with the pressure, which reports four mechanical types of sensors are there, like Pacinian corpuscle, Ruffini ending, Meissner's corpuscle, and Merkel's. These are the basically four major aim, but apart from this, apart from all these four, we have other receptors. These are the main receptors. Now, you can see these receptors are present in the skin at different levels, and depending on the depth their performance changes. Okay. Like you can see here Meissner corpuscle. Meissner corpuscle is at the very shallow depth, at upper layer, so of the epidermis. So, that is why it is actually sense the touch, okay, light touch. Pessiness is very at the depth. So, it actually deals with the pressure depending on the location they are receive different signals, and thermoreceptors are basically two types basically. It is one is warmth, another is cold receptors, and these receptors are also subdivided into two, extreme cold and normal cold, and similarly extreme heat and normal heat. So, mechanical sensory perceptions are like wearer sensation during activity, like if I am wearing a dress and it is not I am moving, I am not making any movement. So, that will give some feeling, but if I start moving, if I do activity, that will be different types of sensation. So, and this prickle, itch and rash sensation. So, sometimes we get this type of sensation, touch and pressure sensation, roughness and scratchiness sensation, okay. Sensations related to thermal stimuli. So, we can, as I have discussed, I have mentioned that it is a cold, warmth, hot pain and cold pain. So, 4 different types of sensations are there, and we can see they are entirely different types of sensors. And if we the researchers, they have established that when a skin is touched with a small worm like a hot pin, if we touch in our skin, what will happen? The in some places we will feel that it is warm, and in some place we may not feel as warm, because the sensors are, if where the warm sensor are there, if we touch the any warm object, that say point, there it will sense, and other place it will not sense, similar to the cold sensor also. Some spots on the skin feel warm or cold and others do not. So, that is thing, and this representation, it shows that you can see that you have this is the normal cold, okay, and this is the cold receptor and this is warm receptor, okay, cold receptor and warm receptor, and this is the cold pain receptor and this is the heat pain receptors. So, what does it mean? Like in normal cold receptors will start its activity around say 5 to 7 8 degree, 6 to 7 degree, and it stops its activity around 40-45. So, 40-45 degree, 42 degree around, say the cold receptors will not be inactive, it will not have any sensation on that. So, and its activity is maximum around say 25 degree Celsius. So, it will sense maximum sensation. Okay. Similarly, for warm receptors it is around say 45 degree Celsius, and beyond 50 degree Celsius this warm receptor does not activate, and cold receptor does not activate below, it is not activate below say 6-7 degree. What does it mean? So, that means when we touch ice say at 0 degree Celsius, say this is 0 degree Celsius. So, what do we feel? Initially we feel cold for certain time. If we press the ice against our body, that means that the temperature will be below 5-6 degree, and gradually it will keep on reducing, goes to 0 degree Celsius. There after certain time, when the sensor starts sensing the temperature 0, it will be pain, it will not, you will not feel the, it will feel numbness, not the cold. Similarly, when we dip our hand in the, if we dip our hand in the boiling water, initially it will look like a warm, but after certain time, after fraction of second, it will be basically pain, that is sensation by the heat pain receptors. So, that is for extreme heat and extreme cold clothing, we should design our clothing in such a fashion that the temperature of our skin should be within the tolerable limit. Okay. And if you see here the distribution of cold and warm receptors, the cold receptors, number of cold receptors are more than the warm receptors. That is why you can see, and in the chest region the number of cold receptors are more. So, if you see and at the chest region, so if we feel chilled, then in that case the sensors from the at the chest region, that cold sensor will sense and it will sense more, because number of sensors are more. So, what we should do, if we wrap our upper part of the body with some clothing or jacket or some wrapper, then immediately will our cold sensation will be reduced. Now, this plot gives the sensation of our sensors. This is actually cold sensor and this is warm sensor. So, sensor of after at the suddenly changing environment. Suppose someone is actually I am from the warm room, I am going outside in a cold environment where say it is snowing, it is very cold. So, suddenly initially the cold sensor sensitivity will increase immediately. So, and that will suddenly feel very cold, and after certain time it will be little bit reduced, like some cold swimming pool, cold pool we are jumping, initially it will feel it is a very cold, and after certain time it will be little bit reduced. Similarly, for warm receptors, if we increase that, like this is the temperature profile, for the certain time it is constant, and when we are dropping the temperature, suppose we are going to from warm room to cold room. So, suddenly this sensation will be there, and suddenly suppose I am jumping into a I am putting my hand in a warm hot water. So, suddenly we will feel warm, okay. And gradually after if it remains there, it will be little bit reduced, the activity, that sensitivity. Now, we must understand our body metabolic heat generation while wearing the protective textiles. It is very important. So, if we sit quietly, okay, in that case we generate metabolic heat 55 to 65 watt per square meter. So, as we increase our movement motion walk, suppose in normal walking. So, we body movement, if we increase, our metabolic heat generation will keep on increasing. So, if we while playing basketball we increase, we have this type of 300 to 450 watt per square meter. So, we know what actually we are doing. If we know what we are actually doing during our after wearing the protective textiles, then we can predict what type of heat we are generating. that heat has to come out from the body, otherwise will not be comfortable. So, our designing the protective textile is very very important. Like a person, a worker is working in front of say furnace. So, here all the heat we are receiving and also body heat also generated. In that case, through the dry heat we cannot dry heat transmission, we cannot keep ourselves comfortable. There the evaporative heat release has to be there. So, this is a very complex scenario. So, metabolic heat loss and sweating, the release of excessive metabolic heat happens through the secretion of sweat. As so, sweat secretion, that actually the sweat management has to be proper. So, we release heat through the secretion of sweat, and if you see the rate of sweating, so it can go up to maximum 4 liters per hour, that much you can imagine. So, 4 liter per hour sweat is being released by a person, and that heat management, that liquid management has to be there. The cooling of clothed human by human body in hot environment is achieved by not by sweating, but by evaporation. So, sweat if it does not get evaporated, like impermeable PPE kit. So, in that case the evaporation is not there, and if it is coated some laminated ones, if evaporation is not there, there the problem will be there, heat. So, in hot and humid condition, so if the humidity is there, that means we cannot actually get the moisture also will not be evaporated. So, there we have to be we have to create certain situation in hot and humid climate. Normal evaporation will not be there, there forced evaporation has to be there by maybe switching on the fan or something. Because sweat cannot evaporate at high humidity and takes out latent heat. So, that will simply drip, the sweat will simply drip off the body and body heat will increase. In case there is a little wind blowing, so then the humidity will be that it will be evaporated. Now, this is taken from the open internet, this source is available. So, you can see here what is the correct microclimate you should keep for a protective textile. So, microclimate target to keep a person comfortable, the microclimate means the climate between our skin and the inner garment, that temperature should be between 31 to 33. So, 32 plus minus 1, it should be that temperature should be there, and the humidity, it should not be too humid. If it is too humid, say 100% humidity is there, then even 32 degrees Celsius he will be very very uncomfortable. So, humidity it should be, we should keep our microclimate little bit dry, 50 plus minus 10% it is the target. So, for that we should create our PPE or our protective textile like that, so that it can release heat or it can release moisture vapor accordingly to create the microclimate. Now, another aspect is the transient heat flow, like from if we wear a clothing, when it is we touch the human skin, and with the clothing is, if it is less than our body temperature or skin temperature, it will immediately draw the heat and we will feel cool, and if it is warmer then heat, it will take the body will take the heat immediately. So, warm cool feeling can be created by using proper fiber or fabric design. So, it is measured by it is called Qmax, by heat flux, immediate instantaneous heat flux Qmax. So, if you see here, so this dotted line, this line, its Qmax is high Qmax, here it is a low Qmax. If it is high Qmax, so if we use this fabric, it will be for summer, because in summer we need that cool fabric, and in winter we need warm fabric. So, lower Qmax means it is warm fabric, because it is taking less heat, it is not taking the heat at all, but in Qmax high means it is taking high amount of heat from the body. So, you can see these are the different fibers. Here linen is among all these fibers, linen is the Qmax is highest, okay, for a particular, with a particular humidity. If we increase the humidity, so the Qmax will increase, like wet cloth will always take more heat, and here you can see the wool has got less Qmax, that means wool is used for warm clothing and linen is used as a cool clothing. Now, after this neurophysiological, then moisture vapor, moisture transmission, it is actually, it has got two aspects, one is in the liquid form, another is in vapor form. First let us discuss the liquid transmission. Liquid transmission actually it's called it has got two stage transmission. One is called wetting and then wicking. So, wetting means it the liquid penetrates inside the fiber structure, and then wicking means it transmits from one place to another place. So, the wicking here liquid water transmission through the clothing primarily depends on the fiber properties. Okay. Fiber water molecular attraction, which is described by surface tension, capillary pore distribution. So, if we have larger capillary pore, that means the capillary pressure will be low and wicking rate will be low. Liquid water transmission, that takes place into two stages, as I have mentioned. First stage is wetting, initial process, and second stage is wicking. Now, we can see here wetting. In wetting, it follows the Young's equation. Actually fiber and air space here inside this here in fiber air space, the air space is actually taken up by the liquid. So, liquid penetrates inside the structure. So, and this is the equation, I am not going into all these issues, and here you can see the once the liquid has penetrated, so this is the capillary channel, okay, and the wicking pressure generates, okay, and this wicking pressure, you can see this is the equation, this is the wicking pressure, which is actually is a function of the inversely proportional to the capillary radius. So, if capillary radius is actually here it is a, it shows basically capillary diameter. So, if it is less, it is a smaller diameter, that means pressure will be high. Okay. So, here by controlling the capillary diameter, we can control the wicking rate, and then comes the moisture in vapor form. Moisture vapor transmission is extremely important to create comfort. So, there it has got moisture vapor transmits from human body to environment in 4 different mechanisms are followed. So, one is the diffusion mechanism of water vapor through the air space between the fibers. Next is the absorption, transmission and desorption. So, the fiber absorb the moisture vapor, it transmits through the material fiber and goes to the other side, and on other side it gets dissolved. So, this is actually this happens in particularly in hydrophilic fiber, and diffusion normally takes place in case of hydrophobic fiber, like where it does not absorb moisture vapor, like polyester, for polyester or any polypropylene. So, where moisture absorption is not there, so the diffusion is there, and for hydrophilic fiber like cotton, wool. So, there this type of absorption, transmission, desorption phenomena takes place. Another mechanism is the adsorption and migration. So, at low temperature moisture gets formed droplet, it is adsorbed at the surface and then migrate to the other surface, and then by forced convection. So, in case of wind chill condition, in windy condition, this forced migration takes place. So, now what are the protective textiles here? Protective textiles are specialized fabrics system engineered to safeguard that we have already discussed, okay, with a different functionality, and there are different applications that we have discussed, firefighter gear, okay, military uniform, ballistic protection, industrial workwear. Okay. So, why comfort is important for protective textiles? So, as we have seen in earlier slide, so these are the different applications. You can see that extreme heat condition, so firefighters are working. So, military uniform for offering the ballistic protection, industrial workwear shielding against chemical exposure, okay, medical garment providing biological barrier. So, in all these applications you will see that the comfort is extremely important, okay, and this comfort important because to enhance the performance. Comfort in protective gear enhance the workers actually to maintain the peak function, okay. It reduces the fatigue. So, they work for long times, they should not be psychologically strained, okay, and increase compliance. When protective clothing are comfortable, users significantly use actually more actually that means they will try to wear this gear, protective gear, and maximize the safety effectiveness. Okay. There are the 4 dimensions, as one is thermal protection, okay. Next is the ergonomic fit, moisture management and tactile comfort. So, this all 4 aspects one has to incorporate in the protective textiles. Thermal regulation should be there, okay? And because to maintain the heat balance, body should not get overheated, and it should ensure ergonomic fit. It should be comfortable, the body mobility should be there. Moisture management, it should actually allow the moisture to get evaporated through the clothing, and also at the same time it should absorb the sweat properly. And tactile comfort, the skin should not be irritating, okay? It should be soft. Thermal comfort, so it maintains the stable body temperature. So, our body core temperature is around say 30, it ranges from 36 to 37 typically, okay. So, that body core temperature maintenance is very important. Skin temperature may vary depending on the environmental condition, but it should maintain the body temperature within a safe region. If the body gets overheated, then there will be problem, that is hyperthermia will be there. If the body gets cooled, then hypothermia will be there. So, in protective textiles application, achieving thermal equilibrium is very important. This heat transmission mechanism in protective textiles, it is basically it follows 4 basic mechanism: conduction, direct heat transfer through fabric material when in contact with the body. So, that means conduction through the fabric. So, fiber conductivity is important, okay, and directly through the fiber or through the textile material, through the fabric it gets transmitted, that is called conduction. Convection, heat exchange through air movement. If there is air movement or any liquid movement, so that if it will get it will get convective heat transmission. And radiation, infrared emission is there, that energy the body surface, it actually from the body surface it can go out, okay, or it can from the external source we can receive the external heat through the radiation. And evaporation, the cooling effect is there. So, it gets receives the latent heat from the human body and we get cooling effect. So, the thermal insulation properties, it is critical in cold environment. So, thermal insulation, we should insulate the way in protective textile in case of extreme cold condition. So, the insulation properties should be high. The thermal barrier, thermal insulation in protective textile function by coating barrier that minimize the heat loss. So, the body heat should not be lost outside. So, we can coat the outside from the, okay, and we say we can create the clothing in such a way that the insulation should be very high. This protection is essential for personnel working in Arctic region or cold storage. Okay. So, this mechanisms there are different mechanisms. One is air entrapment. So, if this is very commonly used mechanism. So, if we can create a clothing which entrap the still air inside the clothing structure. So, that detailed we will discuss in next in some extreme cold module, but the mechanism is air entrapment. the most effective one. So, because air insulation is thermal conductivity is very low. So, you can see 0.024, okay, it is a watt per meter Kelvin. Okay. So, that if we can trap air inside our body, that will be very effective for insulation. And there are different thermal transmission parameters which are used for extreme cold climate clothing, or maybe in other application. So, we must understand different transmission parameters. These parameters are MET is one parameter, CLO, then TOG, permeability index. So, these are the different parameters which explains the thermal transmission through the clothing, and this we will discuss in detail in the next session, and further we will continue with this segment, okay, with this module. Thank you.